Good. So today my talk is on Docker best practices, continuous delivery. The slide's not exactly right. The title's not quite right. So a little more about the build and delivery of Docker containers and images. So I've been doing build tools for quite a long time now and continuous delivery tools. And Docker came along and we jumped on it. I started playing with it a couple years ago. And a lot of the practices that you learn doing really good practices around just clean and hermetic management of artifacts still apply to Docker containers. But there's a few extra little twists and some details that are interesting that I thought I would talk about and share some of the experience I've had in the last couple of years, sort of building out a production deployment of Docker containers and clustering for Riot games. So the agenda today, I'll talk a bit about sort of a simple introduction to containers and images for Docker. I don't know how many people here are already familiar with Docker and containers and building images and all of that. How many people are not super familiar with it? A few. Okay, so I'll go through the first section pretty fast then, and just to set the vocabulary. And we'll talk a little bit about organizing containers, just some philosophy around what's the best way to build a container, what to put in it, what not to put in it. How to craft images. This is where I'll spend a little more time talking about what to put in the image, what to actually build it, and how to construct it. Some different tips there. Sorry, I was going to finish this guy. Then we'll go a little bit more into delivering images, how to get them and how to manage your repos and set things up that way. And then finally the distribution, so how to get all your images out to production in a way that's efficient. And some things you might want to do and keep track of. So containers and images. So the Docker container analogy is really great with all the shipping containers and whales and things. We tend to use the term container for a lot of different things, and a lot of times we mean image when we say container. That's okay as long as people understand the context of it. But sometimes when we're talking about things in detail, we want to be a little more precise. So we'll go into some of the details, specifically which part is the container and which part is the image. So containers encapsulate runtime state. So in Docker, the container represents sort of the scope, the sphere that a process or set of processes has access to in the operating system. And Docker works with the kernel to set up the environment for your container at runtime. And it can control access to certain resources like CPU and memory and block I/O and network I/O, so that a particular container is limited in how much it can get or how much it can grab from the entire machine, right? So you can use it to constrain, contain, and prevent a particular container from taking over a machine. When Docker first came out, it was very limited in what it can do, and it's getting more and more robust in the number of things it can actually manage and control through C groups with Docker. Another cool thing about containers is that they're functional. If you build a container and you design it really well, sort of like a microservice, you could think of it as a mathematical function. So once you've set up your container, you've configured it, you've given it some environment variables, maybe some arguments, and when you do the Docker run, you start the container. It's running. It's kind of a black box, right? Files don't really go in and out. Maybe it's using the file system a little bit for storage, but the basic idea is it's a function in the sense of on the network. So, data comes in on the network, and ports are hit and queries are made and data goes out on the network. So it's a nice black box that's functional. So containers are started from images. So an image is effectively a snapshot of a disk of an operating system or some small subset of an operating system with files added to it. So the process of building an image, you start with some kind of base. You start a container on top of that base, so that container is running, so it's actually running. And part of your Docker file that you use to build the next image tells Docker what to put in there. So you can add files to that running container. You can copy files in, you can run commands in there like apt-get or yum update to get the files in there you want. And then when you finish, you sort of snapshot and you save that image out to disk again. So now you have sort of the next layer on top. So images are like onions, like ogres, and they're built in layers like that. And each layer that's above references the layer below it to say, I'm built from the guy below me, and that guy's built from the guy below me, all the way down to some kind of root image that's bootstrapped from an image, from a loaded OS. And so this concept is sort of a chaining. It's good to keep in mind, because when you're loading your images into an artifact repository later on, we'll see all those layers have to get pushed in there and managed too. But you tend to think of the images when you're working with your particular container and your service that you're trying to run. You don't really care about the top one that you're referencing. All the other ones sort of come along with it based on these sort of back pointers. And when you're ready, and once you've built your image, you have to put it somewhere. So the images then use the docker push command to identify the image you want to push. You push it into the registry. That image, that layer goes into the registry, and all the other layers go in as well, if they're not already in the registry to start with. So the Docker API for saving images has understanding of each layer being sort of a hash of the contents of that layer. And the push command for Docker then interacts with the registry to understand which of those sort of binary hashes are already there. So if a layer is already present, it doesn't need to push it again. So it can be efficient that way, because it can identify that it's already there. So if you, for instance, pull down an OS image, add a file to it, then push your resulting image back up, it's just going to push the delta, that small layer on top. So there's sort of ideas to keep in mind when you're organizing things. And then when you're ready to run and create a container, you run it by referencing the image that you want to run. So you could pull the image down ahead of time to have it on the machine, or you could just say run directly, and Docker will pull it sort of implicitly. But either case, it does a pull for you. So the pull is the action of bringing the images down from the registry, putting them on the local disk so they're cached by Docker, and then the run starts a container from that image. So you can start many containers from the same image and have them running on the same machine. And they're just sort of ephemeral snapshots and runtime environments based on that image as a starting point. Okay, any questions? I guess I could take questions as we go, and we'll see how the time goes. So I went pretty fast through that part. So now we'll talk a little bit about organizing containers. I know when Docker first came out, people thought, oh yeah, go ahead, yeah.
So, so a Docker container, how do you manage like an AMI, AWS AMI? Is it like taking many AMI snapshots as and when you add each LI on top of a base image?
Yeah, so sort of I guess the question I should repeat is, how does the Docker image compare to an AMI? So an AMI, I'm pretty sure, ends up being a complete snapshot of the final state of it. In the case of a Docker image, the Docker image can reproduce the entire state because it references all the things it needs all the way through the chain. There's actually ways of exporting that image as a single tarball if you want to. But typically the way you work with it in the ecosystem of Docker is you just keep the layers separate, and all the tools take care of grabbing the dependencies for you on the fly. It makes things really efficient, and we'll see that as we go along. So when Docker first came out, everybody thought, well, Docker's just like a virtual machine. It's just like a VM image. Like, why is it any different than that? I'm going to put my entire giant application, entire machine into a Docker container. So that's one way to do it. And other people said, no, this should be like microservices. We should put tiny little things. We put one process in every container. And so they had these two camps that have been battling it out a little bit. So there's sort of a more of a conceptual diagram of that. So in the one side, you have sort of a microservice. It has kind of one process in it, pretty much one process, definitely one service. A thin amount of operating system files that it needs, not a lot, because usually it's maybe a small runtime. Maybe it's a Go program that just needs glibc. Or maybe it's Java, but you can run just JRE, headless JRE in there and not have a whole lot of OS around there. But on the other hand, you might have a case where you do want a whole appliance. Like you want to deliver something that's completely self-contained. And there's pros and cons, but in this case, in the appliance world, you can put multiple services in there. You might need to run something like systemd to take care of supervising your processes and restarting them. In this case, the appliance approach treats your container as kind of a self-healing, self-running black box. Now, sort of in the microservice world, it's really nice. The containers are lean and fast and small, but they really depend on orchestration on the outside. So if you're going to deploy 20 instances of one microservice, 30 of another, 40 of another, and hook them all together, you need something to actually do that hooking together, right? So you need some kind of platform underneath. Maybe it's just Docker Compose to put things together one time, or maybe it's Swarm or Kubernetes or Mesos, but you need some kind of orchestration tool to do that. So as long as you're working in that environment where you've got that available, this is the best choice. And this is really, I think, the future of Docker and the future of DevOps with containers and delivering things fast and small and replacing them. This is the way we eventually want to go. But there's sort of this stage right now where the schedulers are competing in a kind of a crazy way. There's sort of like cluster wars going on. Different technologies trying to solve this problem. So there's no clear winner yet. There's no clear way to deliver like an appliance as something like, are you going to deliver your appliance with Kubernetes? You're going to deliver it with a Docker Compose file. So I think it's okay to deliver appliance containers for these certain use cases. Like if you are wanting to deliver something that's self-contained, you can hand to a customer and say, here's a Docker image that will run all my stuff. And this is kind of how Artifactory runs itself with Nginx together in Java, and it all just works, and that's a nice use case. So I think that's fair in this time frame. Hopefully these cluster wars will settle down and we'll have a more universal way of describing a configuration or a topology of a stack that we want to deploy. So I think that will be coming. So any questions on that little opinion piece? No? Okay. We'll talk a little bit about crafting images.
Actually, one question on that. One of the things we're kind of dealing with is how we deal with events between those different microservices and the best way to kind of handle and control when one is completely dependent on another service.
Right. So events between them?
Yeah.
Yeah, so I think that's part of the whole ecosystem of bringing up a cluster is you need a number of like infrastructure pieces that are part of the clustering system. Now, some of them might provide it, some might not, but you need some kind of way of doing service discovery. And you also need to make sure when you're designing your microservice apps that they're really sort of 12-factor, right? So they need to be able to come up, and one of the factors I can't remember is having to do with being resilient to downstream dependencies not being there. So becoming passive, waiting for the downstream dependencies to come back so that the order of instantiation of your services shouldn't matter. So otherwise it becomes so complex for an orchestrator to even deal with starting a sequence of microservices. It's better if they're all robust and self-contained and they can just bring them up and then they glue themselves together automatically. But you do need some kind of at least service discovery, which could be DNS based, or you could be load balancer based, or you could have your own microservice that does discovery like Netflix with Eureka. Okay. Crafting images. So I think one of the main things, so Docker's webpage and the documentation, they have a nice page on tips on Docker file best practices. So a lot of the ones that I'm mentioning are there. So that's a good resource to go to. And I'll put the link up on the screen later on. But I think one of the ultimate goal is to keep your images lean and mean, right? So keep them small. You don't want to put things into the images that you don't need. And sort of why is that? I mean, I think the three main things you'll see is security, speed, and size. And letting stuff into the containers that you don't know about or you don't need just because it's quick. I mean, it's fine when you're doing development. Definitely don't worry about it. Like you're building stuff on your desktop, just grab the base you want. But at some point you're going to go to production. This is something you should be thinking about is let's start trimming this down and pick the best base to use and pick the best kind of what do the packages really need to add, which ones do we not need to add, and do some work in getting that pruned down. So the three whys, so security. So having more things in your container at runtime than you need increases the chance that some of those things are going to have problems. So just like on stage this morning with the scary, the old libraries and the bad jars and the scary malware in there, there's going to be stuff that may end up leaking into your container that, I mean, you identify it as a vulnerability, maybe with X-ray. You say, look, there's a thing inside your container. We know that this is suspect and there's a security flaw in it and you need to replace it. But as a developer, you might know, well, I'm not actually using that component. But the AppSec guys are going to say, no, but you have it in your container, right? You don't know. So at a company-wide level or tooling automation level, you'll see these risky components inside your containers, and you won't know if they're being used or not because they're there. So the best thing to do is just to not put them there in the first place. So trim down your images so that they only reference the things you actually need, so that you're not churning through a lot of security things. So make it easier for the security guys to find the real problems. The other Y is speed. Just the bigger and fatter your images are, and the less well organized they are, they're just going to take a lot longer to move over the network. So this may end up being for you if you're doing international global deploys. That may be significant latency in deployment around the world. This just may be just overloading your internal networks because you're just moving too much stuff around, or maybe cost. If you're paying for WAN links that are now you have to upgrade because you're shoving fat stuff through there that doesn't really need to be there. So that's another reason to keep that in mind. And the last one is sort of related to speed, but it's just space. So on the actual Docker host, the Docker daemon is not that great at dealing with lots and lots of layers, and it can get clogged up pretty easily if you don't do periodic garbage collection. Some of the cluster managers like Kubernetes have sort of a built-in garbage collector, and probably Mesos as well. So they can tell when images aren't being used on the host anymore and clean them up. But if you're running something simpler and you just want to do simple deploys, maybe with Docker Compose, and you don't have automation around that, it's pretty easy to overload the disk and actually, fill the disk up over time, especially like we've had this with build nodes, where just every few days, the build node will go down. We don't know why. Oh, it's full of images. So cleaning that up is something that you'll need to deal with. But having lots of fat images that use up too much space just makes the problem worse. So how do you solve these problems? So it's all about the base, all your base. So there's a few rules about selecting the base image. The base image is really important. You want to get an official base. And earlier this morning they talked about putting your bases in Artifactory, and I think that's fine. That's a good idea too. We haven't gone that far yet. We're still grabbing official bases from Docker Hub, and I think that's okay. As long as you're really conscious about only grabbing the official one. So if you want CentOS, get CentOS from CentOS, right? Don't get some guy's copy of CentOS that might be a little bit neater and trimmer, and he's put some cool stuff in it, but you don't really know where it is. Maybe you test it once, but you don't know what it's going to be like 6 months from now when you pull the next version of it. So you just want the standard ones. You do want to lock to a specific version. There's a couple techniques for doing that. If you're just building directly from like Docker Hub, you want to just specify and pin down onto the tag that's a complete version, so that you know what you started with, so that you have effectively a version chain that you can follow. Now, Docker unfortunately has this ability. It doesn't have immutable tags. They're always mutable. Effectively, they can change. So something that's tagged version 7.2, next month might be still 7.2, but could be different bits. But you do the best you can and tag to the finest grain version that's available. You can also pull, so if you are using Artifactory or some other local internal repo as a cache, you can control that snapshotting and do that yourself, right? So you could pull down the official version, that's the latest one you want, and lock it down, maybe add your own tag to say this is the one we used on this day. And then build from there, and always build from one that you know about. And then standard tips about stay near latest, so always try to keep up and always continually update and rebuild against newer versions to make sure you have all the security updates and performance fixes and everything. And also choose the best base to start from. So don't always just go grab the biggest Ubuntu or CentOS that you can find that has everything. It makes it easy because all the stuff you might ever need on a real host machine is just going to be in the container. You probably don't need all of it. So you might want to look at some of the suggested bases. So I gave a talk like this internally a couple years ago when we were first grabbing Docker and starting to work with Docker, and we created a list of recommended bases internally. And now I noticed when I reviewed this the other day, they're a lot smaller than they were 2 years ago. So I think these guys who are building the official builds of standard distros are getting smaller and smaller because they're aware that they don't need to put everything in the kitchen sink into the base. So they're making them leaner. So these choices are all really good. If you're a CentOS Red Hat shop, the CentOS is really good. We've typically used Debian for a long time for what we thought was the small one that had everything. But it turns out the newest Ubuntu is even smaller than Debian. So I don't know. Those are really good choices. Now, Alpine is great if you really don't need a lot of OS at all. So this is the base image that we use for all of our Go tools that we build. So a lot of our internal infrastructure runtime is built in Go, and then we just build an Alpine-based container and deploy it. So we end up with a Go binary that's maybe 10 megabytes, and Alpine's another 5. So we have these images that are 15 to 20 megabytes for the entire image, for the whole runtime. So that's pretty good. And also, some people have played around with just building from scratch. So you can say, I just want to build from scratch, you got no image at all. You have to put every file on there that you need. So you could do it with some languages like Go, where you could build statically and pull everything into your binary. There's often other files that are missing, like you often will need your CA certs and things like that. So it's a bit of a exploration to get that done. Figure out what you need at runtime that you've missed. But if you're really trying to make something tiny, that's the way to start. Yeah, question?
How do you think about if the Go maintainers have a Go-based image built on Alpine, do you go with that one layer up? And they usually tout, all the frameworks and languages tout that they have the best.
Yeah,
What you need in the OS to run Go versus building that Go layer on top of your Alpine.
right. So if somebody, like you're saying, the language providers might have a base. So I think different languages will be different in this case. So with Go, there really is no runtime other than glibc. So, because Go is compiled, so you have a binary that's native code. So you don't really need a Go runtime. You could pick. I mean, maybe if the Go guys had provided one that's here's a stripped down Debian that has just the glib and the other libraries that Go needs, that might be a good choice. I'm not aware of that. Other languages like Java need the JVM. So having like a JVM running on top of Alpine, if it's coming from an official distro, maybe from Oracle, that would be very interesting, very compelling to look into.
I'm just wondering, you end up using various bases.
Yeah.
Like, at Tomcat use, Ubuntu and through using Debian or different kinds of.
No, that's true. That's a good point. You may end up with different routes that way, and you have to trade that off. I'll mention that in a couple slides. So I suggest generally building a small number of root bases, or I call them your own base. So this is where you might grab the particular Debian or CentOS. Just do a really simple build, do the update, and add any kind of small things that your company might need, for everybody in your company, and then save that as one image. And then put that in your prod repo area for everybody else to use as the base, and go from there. So this is one good technique for sort of locking down and having a well-known root image that everybody can reference. And maybe you have two. So maybe some guys like Debian, some guys like CentOS-based ones, because different teams use different tools. So then you can have two. But two is better than having 25, because everybody did their own at different times, and they're all a little bit different. What you don't want is equivalent but binary different, because it's just a waste. And as you mentioned, so this is the slide. I don't know how easy that is to read. The idea is that when you're building Docker images, they reference their parent. So at the end of the day, you have something that looks like a tree, where your container image that you're actually running your applications in are at the top, and they reference maybe a base image that has some library things in it, and then another one which is sort of your company's blessed image, which then references the official image. So you've got this tree. If you can consolidate to a small number of sort of roots and shared intermediate bases, you end up having a lot less copies that are similar but binary different. So that's your point. So reducing it to a small number, if you can build everything on top of the base distro that you like and you prefer, that's great.
I am going to touch on how you minimize the number of fields of base that you use in the company. Like, I manage Docker compose files at scale that you change the links there everywhere, or how Artifactory can help with that?
I'll talk a little bit about some things. We can ask questions at the end. I'll try to go through, and then if I haven't covered everything.
That's very interesting.
Yeah, okay. Was there another question in the back? Yeah.
I have a question. How do you manage the versioning of all the layers? You have CentOS, and then you have Java, and then you have Tomcat. How do you version that? And then maybe a follow-up question is, let's say you then need to update your base image of CentOS. How do you update all the images that depend on that one?
Right, okay, so keeping track of the versions of things. I mean, what my team has typically done, and this practice is sort of common around our company, but it's not set in stone, is to just put suffixes on it. So like if you're gonna grab CentOS, 7.2.1511, and you're gonna build it and add some stuff to it, then we're gonna call that, 17.2.1511.1. So that's our extra thing on top of that. And then as you build the layers up above, you just, I think just build incremental build numbers, suffixes at the end to keep track of what you've done. And sort of, the history of like which version of Java on top of which version of CentOS with which version of some other thing, it can get really complex. So you don't have to encode everything into it. As long as you can determine the sequence and the uniqueness of it, I think that's sufficient.
Okay, and how would you go about updating all the images? Let's say you have to update the very bottom one.
Yeah, okay, I'll talk a little bit about that going forward. I have suggestions, but no like definitive answer. But JFrog's got some nice new tools that we can talk about later on. Another trick to kind of reduce the number of tiny little images that really, or layers, sorry, that don't add much value is to squish all your commands in your Docker file into sort of you add them together. So each run command in the Docker file or each add command in the Docker file ends up being a layer. And so if you do add this, add this, add this, you end up with 20 layers. That just adds more and more indirection. It ends up, I mean, if they're small, you think, well, they're not very big, but there's a bunch of metadata for each layer, and each layer ends up requiring a transaction to go get it across the network. And if you're doing things in kind of a haphazard sequence in your Docker file, everybody's Docker file is going to be a little different, and all their layers are going to be a little different. So sort of the recommendation from the Docker guys is that your basic stuff should be kind of sorted, alphabetically squished together into a small number of commands. I mean, if you think about it, now we're building our images with shell scripts. In some ways, it seems like we've gone backwards, but it is very flexible and simple. And the Docker file is so linear that this is really a nice, reasonable bite size to deal with. Okay, so now we know how to craft our images and put them together. We'll have to deliver them. I was very creative with the clip art, don't you think? Yes, one question?
As far as the crafting of images, what would your opinion be about, like, for a lot of work that's been done with, like, Vagrant, Ansible, Chef, and Puppet, I mean, there's a lot of ways of, like, how to not do all that work being done to build these environments with those tools. How can you transfer that into Docker?
Right, yeah, so transferring the work. I mean, I think they approach the problem differently. So Ansible, Chef, Puppet, they're approaching a slightly different problem. They're trying to take a very large system, like an entire host machine that's maybe running many apps with many shared libraries, and converge it into a new state. Whereas with Docker, you're always building images from the ground up. So you never have to worry about mutating any files or changing things, or in the fact you're only running one thing on that image, in that image, right? So that's why you want the containers to be small. You don't have to worry about conflicts because there's only one use of it. So I think because it's a much simpler problem, the solution could be much simpler. So it really is more like a makefile. It's just saying start from here and add these things. So you could trace it back from 0 bytes all the way to the stuff you put on there. And you know what's going to be on there is exactly what you said. You don't have to worry about mutating anything. So, I mean, I think you can learn from what you've done with Chef and Puppet and how you've built your systems and understand how that's gone, but you probably won't get much value trying to reuse those files. Okay, so delivering images. So how are we going to deliver the image into a way where they can be shared? So not deploying, but just the delivering part. So it is important, everybody knows here, I mean, this is the conference, everybody knows you need to continuously integrate, build things fast, and get them out the door. But part of this, and there's some, as it was mentioned just a bit ago, how do you keep track of who depends on what? And there's not really any magic solution for that now. But some tools like X-Ray could do this. You can also use Artifactory and keep track of metadata and dependencies. So that, or you could even create your Jenkins builds to actually follow the chain of dependencies for your base images, right? So when you have you find a vulnerability, or you just decide we need to move to the newest version of Debian or CentOS, that's everybody who's dependent on us needs to get rebuilt. So you want that to be automated. So you can either do that with a chain of Jenkins jobs, or you can do that with Artifactory and looking for tags and triggering builds again. But it's important to set some process up around that so you can find all the apps that depend on the things that you realize need to be changed. And you want that to just be automatic. So even if the team that's in charge of the base image says, oh, we have a vulnerability, we have a patch, let's apply the patch and rebuild, it should be automatic all the way out to the app teams, dev teams get a new version of their image automatically without having to be involved if they don't want to be involved. So then, where do you put the images when you've built them? So there's a few choices. People here probably already all know these. There's the open source registry that's available that came out, it's been around. It's been updated since Docker first put it out. They now have an enterprise product, the Trusted Registry, which is a good choice. But I like Artifactory, and that's, I mean, this is the right place to say I like Artifactory. For me, they're not even, yeah. I'm not even getting paid to say that, although I should be, right? I mean, for me, the JFrog guys know how to build binary repositories that are efficient and scale. And Docker is just another kind of artifact. And even though it's got some weirdnesses and some funniness with its APIs, and at the end of the day, it's just a binary artifact that you can identify by its hash and put metadata on it and move it around. And so Artifactory does a really good job with all that. So if you use an Artifactory, it's a great Docker repo. If you're starting from scratch, you're a small company, or you're just some guy who wants to set up something small, then the open source one is fine. And maybe if you're a shop that's already getting some of the enterprise products from Docker, then maybe their Trusted Registry would be a good choice. So the first thing you want to set up is decide where your source of truth is going to be for your registry, your repository, Artifactory, and make sure that has sort of an appropriate level of availability for you. At least have some kind of resilient backing store. So something with maybe RDS and S3 if you're in Amazon or have a good link to Amazon. Resilient file system and resilient database. And if you need it to be available to all your developers, around the clock, then you do want to use the HA version of Artifactory, which will give you enough redundancy and active failover so that you're not going to lose your master repository when you need when things are going crazy. You need to push a new thing to production. So you want a nice, robust source of truth in your master server. And so this is what we have. So at Riot, we have one set up in our main data center that we run in Las Vegas, and that's where we keep all our masters, and that's our main copy of stuff. And we've actually organized our repos sort of around, they're kind of the use case. So we have an Artifactory cluster just for Docker, because that's kind of the use case for that. We have other Artifactories we use for other purposes, and we've divided it up that way. I don't think that's necessary. It kind of depends on the size and scale of your teams and who's running what. So that worked for us because my team and our large team kind of does the clustering and the Docker stuff. So we were running the one that we wanted to just do Docker with. There's one thing that we've discovered the hard way. This is kind of funny. Is it's a good idea to divide up your repository into a sort of a dev section and a prod section. The dev section will have that's the default place where stuff goes out, when it's produced in the build. And it'll have a lot of churn. Developers are building things, CI is running fast, and it'll be full of things that you don't necessarily need to use, right? They may be just broken, they may be totally fine, but then completely replaced, an hour later when the next CI builds. So it's just going to be noisy and churny. And you want to create and carve out a little area, a separate little logical repo that says this is where our prod stuff goes. And so once you've vetted things and you've run through testing, you can then have a promotion process that copies stuff over 10 minutes. Okay, that copies things over into the prod repo. So this will give you some benefits later on. Makes it easy for people to find things. And then when we get to distribution, it makes that a lot simpler too. Yeah, question?
Do you typically just retag stuff so that it goes to production? Do you re-upload it, or do you rebuild it from scratch?
So yeah, so rebuilding, uploading, I would say you would use Artifactory APIs to put a label on it, and then promote it to the other logical repo within Artifactory. So it's a zero copy. Yeah, so generally you don't need to rebuild it. It's something to avoid, and definitely don't need to upload it. So yeah, so that's good. Now there's another thing that we found out the hard way too. Team permissions. We manage the central repository for lots of different teams. This is really hard to read. But we figured out that in case people aren't aware of this feature in Artifactory, the permission object is really powerful. And that's really all you need to do is to create the representation of a team. So in the permission object, we can assign a permission object for a Docker org, sort of a Docker image organization with wildcards here. That's definitely hard to read. And then add the users to that, and we could add them with scripting that way. So in this case, I made a team for the .d team, and I put myself in it, and we have permissions to do everything we want to in our repo. There's a group object in Artifactory, which is really handy for integrating with LDAP, but if you're not doing LDAP, you actually don't need that, and it saves a step, makes things less complicated. We found that, yeah. So for us, that's something we learned. Yeah. Yeah, go ahead. Yeah, I'm just going to mention right here. I don't. Yeah. So. Yeah.
So I assume you have like a few different repositories for different development teams. Do you have like a concept of a role, which would be just a separate step between the team and like for instance like admins, like role admins in this repo means that and that's a development group or is it like an operations group for this application, and then there's developers or
Yeah, the permissions that are available in Artifactory are what we leverage. So I didn't really get a good shot of it in here. But so the team members can have different, you can manage, you can delete, overwrite, deploy. There's a few different permissions that are built into Artifactory, and we just use those. So that's fine. We definitely have like dozens of different teams, and each team has all the engineers and members of the team that have access to the repo. And they pretty much all have rewrite, full access to it. And then we have tooling that's sort of more role-based, and the tooling then ends up being read-only. So like our actually cluster deploying tool is read-only access to all the repos, so they could deploy. I got to go a little faster, and then we can get more questions later on. It's important to clean things up. I don't have a perfect solution for it. We had this problem, it crops up everywhere I go, and you kind of come up with some basic ideas. So splitting the repo into two helps a lot because your dev repo has a lot more churn, and you need to be a little more aggressive about cleaning things up. And you can do things like detect if a particular image is never promoted, never referenced, and completely made obsolete by a new one. It's been superseded. That can be deleted right away. You can set up a nice TTL for things that, once they're unused for a certain period of time, you can clean them up. And if you segregated images into prod, then okay, your prod TTL could be much longer. You can reference into production to make sure that things that are still running still have their image available. So you can cross-reference that way. So these are not complete solutions, but just things to check.
Is there something in Artifactory that builder out that you can do that?
All the metadata is available inside of Artifactory so that you can find out all this information. And so you can either write a user plugin to do it, or I've done in the past is write a Jenkins job that gathers the metadata. So I think at Netflix we did one, it was a combination. We had a user plugin that gathered the metadata and produced a dump, and then we pulled it into Jenkins and examined it, and then did a bunch of deletes with the command line tool. So the CLI. So now Artifactory's got its own really nice CLI. You could do probably a lot more of the work in the user plugins to find out the candidates for deletion and tag them, and then have the tool go and get rid of them. Yeah?
If you use Jenkins to build an image and use the Artifactory plugin, you can actually set the expiration column.
Ah, okay. Well, there you go. Very good. Okay, so the Artifactory plugin can give you an expiration. That's very good. And then I guess you would supersede it if you promoted something, right? And then you want it to last a little bit longer.
How is it handled if you have multiple Artifactory servers that replicate or mirror? The last exit date, is it global or is it per instance?
So let me finish talking about distribution, and that might answer your question. So I'll talk now about how you distribute the images to prod. So remember, I sort of recommended, what we're doing is have one master source of truth. So that's where all the metadata really, that's a source of truth for the metadata. In our case, we have lots of global data centers that we push our images out to. So all over the world, we have our little clusters running, and they need to get to the images. So we do push replication, and we use, well, I'll show you the details of that. But the idea is we want the copies of the images that we're going to need in prod to be pushed out into prod and be available so that when we're bringing up nodes and Docker needs to run, or a machine goes down and we need to restart the same containers on a new machine, that we want that to be fast. So we want to reduce the latency for redeploy, or the cluster manager needing to move an image around to start a container somewhere. And we also want to reduce the WAN bandwidth. So we don't want to be pulling images over international network continuously. We want to push it once and have it cached on the remote. We use the Artifactory MULTIPUSH replication. So whenever image gets pushed into the master, we replicate it out with a sort of a trigger-based push. It works really well. One of the mistakes that we made, well, I'll show that in a second. This is just really handy. And then you can also have a cron base. So in case some of them are dropped on the network, the cron base will do a sweep every night or every few nights to make sure that all the images get pushed over. So that's just a handy feature that's built into Artifactory. And we push out, we're now to 7 remotes, and we're going to double that. So all over the world we're pushing. So this is the key thing. So one of the reasons that we're going back and re-architecting the way we built our master is that we didn't do the segregation initially. So we're replicating this all over the world, which is clogging our pipes. And we recommend only replicating that all over the world. And that's one of the reasons. And there's other, it's just so slow to push all that stuff. Like if we want to bring up a new small data center, maybe in GCE for a team that needs a copy of everything, it's going to take a while to move all those big piles of stuff over that they don't really need. So having it lean and mean makes it more agile and quick to bring up new repositories where you need them. In our case, yeah, we didn't think about it. We brought it up. It was working, and then just our own success. Everybody started using our repo, and it got really full. So we're running now like 125,000 images, and we can't tell what's what. So we're going to go through the exercise of cleaning this up. And that's it. Questions?